Hello everyone, my name is Ivana Mitrović and it's a great pleasure for me today to present the work of my team and myself also with the title Production of Bioagent for Sustainable Control of Apple Fusarium Rot in Storage by Streptomyces Hygroscopicus. These are the members of my team and we all work in University of Novi Sad, Faculty of Technology, NoviSad, Serbia, in Department of Biotechnology and Pharmaceutical Engineering, except Mila, she works in Faculty of Agriculture, NoviSad. Well, apple fruit is one of the most important and the most commonly used fruit in the world because adults, children, and baby as well use apple fruit just like a native fruit or some kind of apple products like juice, jam, compote, etc. And because of that, the health of apple fruit are very important. Thanks to its long storage capability, apples are the subject of worldwide trade through the year, and the quality storage condition enable them to be sold on the market at the time when they reach their highest price. The apple market is very damaging, so after successful production in the field, growers have to pay special attention to their storage. And according to definition, healthy apple fruit is a fruit without pathogenic fungi, but also without synthetic pesticides or residues. During storage, transport, and marketing as well, apple can be infected by different phytopathogenic fungi, which can cause apple fungal disease. The following phytopathogenic fungi are listed as the most important causative agents of apple fruit rot in the storage, and all because of that, apple fruits are a very good medium for microorganisms because it's a very full of water and the sugar. And the most important of all of these phytopathogenic fungi is the species Fusarium, especially in this work. And the Fusarium species infection is recognized as white, rose, or reddish mycelium developing initially in the apple core. And on the apple fruit, it causes light brown, wet rot spreading destructively into the surrounding cortex of infected apples. And that was the representative of these two pictures. On the other hand, control of apple fungal disease is performed by synthetic pesticides. The use of a chemical agent is commonly common in plant protection. However, the intensive use of chemical agent in modern agriculture, including those used to control phytopathogenic fungi, has led to several problems related to environmental pollution and emergence of resistant strain. And this is the most important disadvantages of synthetic pesticides, and that is contamination of crop products with harmful chemical residues, contamination of soil and groundwater, health risk to those who apply agrochemicals, also genetic resistance, and most chemical pesticides are non-specific. Because all the above, in the last few years, in focusing the search of alternative methods that can reduce the use of toxic agrochemicals, and one of the options is usage of beneficial microorganisms. So in this study, Streptomyces hygroscopicus isolate from a natural environment, actually soil sample from a territory in the Republic of Serbia, was used as a microorganism antagonist, and this was the medium for grow, which contain glucose as a carbon source and soybean meal as a nitrogen source. So the grow of Streptomyces hygroscopicus and preparing of inoculum was carried out in a rotary shaker on 150 RPM. Temperature was 26 plus minus 1 Celsius degrees, and pH of the medium was 7.2. And the experiment, production of antifungal metabolites by Streptomyces hygroscopicus was carried out in 3-liter stir tank laboratory bioreactor during 7 days. This bioreactor was represented in this picture in the slide. and fermentation was carried out at 26 Celsius degree with aeration rate of 1.5 and agitation rate of 150 rpm. For the production of antifungal metabolites in this study, we used glycerol as a carbon source because Streptomyces are known to have a great potential to use glycerol, and some scientists have proven that the additional to pure glycerol, this genus can also grow and produce active metabolites in medium containing waste glycerol. However, production of biofungicides is an important step to its commercial use, but one of the biggest problems of production and application of biological products is their higher price. Therefore, a considerable interest has been shown in usage of agricultural waste and also byproducts from food industry as cultivation medium in order to reduce the production and upstream cost. Regarding this fact, pure glycerol, which can use in this study, and potentially use of waste glycerol seems to be a promising component in cultivation media used for production of active agent by Streptomyces hygroscopicus. The aim of this work was to analyze bioprocess parameters and to examine that which stage of bioprocess actually production of antifungal metabolites occurs. Activity of bioagent production was tested every 12 hours of cultivation, and the cultivation liquid was centrifuged in 10,000 rpm for 10 minutes, and only liquid phase, actually supernatant of Streptomyces hygroscopicus, was used for determination of residual glycerol by instrumental method, high performance liquid chromatography, also residual nitrogen determination using Kjeldal method, but also for determination of cell biomass. In vitro and in planta antagonistic activity assay was also performed. In vitro antagonistic activity assay. So we use two isolates of Fusarium avanaceum marked as Ka12 and Ka13 as a test microorganism, and Petri plates with 85 millimeter diameter we use for in vitro testing by Wells technique. Before use, culture liquid of tested microorganism was filtered through the double layer of the sterile cheesecloth. 3 wells with the diameter of 15 millimeter represent one treatment, and 100 microliters of the test liquid, Streptomyces hygroscopicus test liquid, was added in each well. In control plates, also 100 microliter of sterile distillated water was added to wells. In vitro antagonistic activity of the Streptomyces hygroscopicus supernatant against 2 Fusarium isolates grow on potato dextrose agar was determined every 12 hours of cultivation in the bioreactor, and after incubation of on 27 Celsius degrees during the 72 hour, we measure inhibition zone diameter, and that was diameter actually zone around wells with no visible mycelial growth. Implant antagonistic activity assay was performed to confirm antifungal activity on mature apple, golden delicious, fruits of a similar size. So 10 milliliter drop of Streptomyces hygroscopicus supernatant was added to each wound, and wound was 4 millimeter diameter and 3 millimeter depth prior to fungal inoculation. And the fungal inoculation was performed by adding a mycelial plug 3 millimeter diameter of the tested fungal isolates. After incubation in plastic container in temperature between 21 and 23 Celsius degrees with relative humidity 97%. After 7 days, after the diameter of developed necrosis lesion was in order to define the course of cultivation in the laboratory bioreactor, content of the most important nutrients, and that is carbon and nitrogen sources, during the cultivation were measured. Also, change in dry weight of the cell was monitored as indicator of the change in the biomass content of the microorganism producer. The results are shown in a graph on the left side of the slide, and based on the data obtained in the graph, it can be observed that consumption of glycerol is more intense at the start of bioprocess, up to 72 hours. This indicates that Streptomyces hygroscopicus use this nutrient during the biomass multiplication phase. On the other hand, nitrogen is required by microorganisms both for growth and multiplication, but very often also for the production of the desired metabolites. Results of biomass growth show that exponential phase lasts until the third day, when stationary phase of the bioprocess, in which the consumption of nutrients is significantly reduced, begins. And the time course of residual glycerol content, residual nitrogen content, and cell biomass during 7 days of Streptomyces hygroscopicus cultivation in bioreactor is represented in this graph on the left side of the slide. In vitro results. Graph left represents mean value of mycelial growth inhibition zone diameter of 2 Fusarium avanasium isolates caused by Streptomyces hygroscopicus supernatant during 7 days of cultivation on medium containing glycerol. According to fact that inhibition zone diameter over 22 millimeters indicated that the applied antifungal agent is potentially high efficient. From obtained results, it can be concluded that impressive antifungal activity was achieved after third day of Streptomyces hygroscopicus cultivation under defined condition. However, the highest production of antagonistic agent is achieved in 96-hour cultivation. In this time of cultivation, Streptomyces hygroscopicus supernatant form inhibition zone diameter of Fusarium avanasium Ka12 and Ka13 of 4333 and 4067 millimeter respectively. And this is represented on this picture on the right side of this slide. In plantar results, from this figure, it can be seen that Fusarium avanasium Ka12 isolate was more sensitive to produce antagonistic agent, forming a mean necrosis zone diameter of 7.67 millimeters, while isolates Fusarium avanasium Ka13 mycelia grow forming a mean necrosis zone diameter of 667 millimeters. It can be concluded that necrosis diameter, which were measured on artificially inoculated apple fruit, compared to necrosis diameter measured on control sample, were 2.8 and 2.17 times smaller for isolates Ka12 and Ka13 respectively. These results show that there were statistically significant differences between treated and non-treated, actually control fruits. This indicates that antagonistic agent produced by Streptomyces hygroscopicus in the bioreactor under a well-defined condition on the medium with glycerol show very good suppression of Fusarium avanasium Ka12 and Ka13 mycelial growth. And conclusions. Streptomyces hygroscopicus shows great potential as a tool for biological control of Fusarium avanasium isolated from stored apple fruits. The results show that the highest antifungal activity of Streptomyces hygroscopicus supernatant occurred in 96-hour cultivation under defined condition. And under these conditions, Streptomyces hygroscopicus supernatant resulted in a greater inhibition zone of 4333 and 4067 mm for Fusarium avanaceum, Ka12 and Ka13 isolates respectively. Also, these results were verified in implanter studies, whereby it was found that necrosis diameter on treated apples were significantly smaller compared to non-treated control apple fruit. Thank you for your attention. The authors gratefully acknowledge the support of Ministry of Education, Science and Technological Development of Republic of Serbia with this project number. Thank you once again.